Welcome to our next Stat 212 video. In this video we're going to talk about evaluating statistical results by just looking at a few things here. Let me get this over here. So the first thing that I want to talk about is cherry picking. So cherry picking is something that's commonly used when presenting statistical results. It's something that a lot of us do, and we should be cautious of it when we're reading other people's statistical work. And that is when you're just kind of being very careful what results you actually present versus what you might kind of leave unmentioned. So you see that a lot in graphical displays. You can even see that just in terms of kind of playing around a little bit with how you frame your results. We'll look at a few examples here. So the name for cherry picking just comes from the idea that whenever you're picking cherries or fruit in general, you're probably picking the best, right? So you're not going to just pick a truly random sample of cherries that are on trees. You're going to be picking the ones that are actually ripe and done. So obviously the cherries that you have in your basket are not actually representing the cherries in your on the plants or on the trees as they are. So the same thing happens whenever we present data. We're presenting the data, we're presenting the results that present a particular case, while sometimes leaving out other results as well. So here's an example of a visualization that is cherry picking. So this visualization represents job losses by quarter, and there's a couple things that we should point out about this presentation. So the first issue that I would point out here is that the scale isn't really consistent. Right, so I have December 2007, September 2008, March 2009, June 2010, and one thing that you might point out here is that this period of time should be the longest. This is about 15 months of time. Compare that to September to March, which should only be about 6 or 7 months of time, so we'll say about 7 months, I'd say. And then again to December 2007, that should be about 9 months. So already there's something kind of strange about the scale. Something else that I would point out here is that there's only 4 values being reported. And why is that the case? Why am I choosing values at these strange kind of marks as opposed to a very consistent mark, like a dot for every month would make a lot more sense for this graph. So kind of these 4 results seem to be kind of cherry-picked for this particular presentation. So if we go back to the data source, which would be the the U.S. Jobs claims or job losses per quarter, I guess this would really be the unemployment rate. If we go back to that source and regraph this by making the scale consistent as well as providing a more comprehensive set of data, we see a very different story here, where job losses aren't actually just steadily going up over this period of time. They're actually plateauing and kind of remaining steady at around this 15 million mark. So this is a case where cherry picking really changed the story. We should be really careful about the visualizations that we kind of come across and what kind of conclusions we're making from it, and just ask, is there anything kind of unusual or possibly deceiving about this data and the way it's been presented? Like what would be anomalous about this presentation? It's not just a visualization that's going to be strange. So there's other things. Sorry, my cat's being strange. There's other things that can go wrong as well. I mean, we don't talk about it so much, but I could also just cherry pick statistics that I report and not report other things. We don't get super detailed in that, but we just want to be aware of cherry picking as a thing that can happen. Something else to be aware of would be making claims from only anecdotal evidence. So just being aware of our data source and how objectively sourced that data is versus just going across the experiences that I have and people that I know have may not be the full picture. This is really important today, especially because if you think about the way that our media works, especially social media, we're often living in echo chambers. We're often only hearing very non-neutral views and non-neutral data sources for our information. But I mean more than just the news that we get, just the information that we have. If we rely very much on anecdotal evidence, like us and our friends, we're just not getting a full picture of what's going on. So I have an example here. Let's say that I get a flu vaccine 1 year, and then I contract the flu that season. Well, maybe the next season I'm thinking, well, maybe I shouldn't get the flu vaccine because it didn't really work for me. But if I'm deciding that from just my anecdotal evidence, from my sample size of one, how good is my data really? And, just from 1 year, I happen to be in the whatever it is, the 40 to 60% of people for which the flu vaccine doesn't necessarily work. As you know, the flu vaccine is not 100% effective in keeping you away from the flu. There's still a chance that you can get the flu. And just because that happens one time doesn't mean that I should never get the flu vaccine again. So that would be an example of anecdotal evidence driving my decision making. So we should be really cautious of that whenever we're making decisions, that we should strive for more objectively sourced source of data. And the third thing that I want to mention is just searching for answers under the cloud of a confirmation bias. So we as humans like to find information that already aligns with our views and provides a conclusion that we have already decided that we like. It's a lot harder to solicit information that goes against what we already think, because psychologically that creates cognitive dissonance, and that's a lot harder for us to grapple with. It's a lot easier for us to maintain a certain psychological status quo with what we believe and what information we'd like to find to support that. So I have another example here. Let's see, I think it's related to vitamins. Okay, yeah. So let's say that I don't like to take vitamins. Then two things might happen as a result of that. One is that I might pay more attention to information that tells me that vitamins are not that important, because it just already goes with what I'm looking for. So even though I might see information that says vitamins are good, and I might see information that says vitamins really aren't that good, I'm probably just going to pay more attention to the one that I already like. Secondly, I might be soliciting information more likely that fits that. So if I'm doing a Google search related to vitamins, I might be typing in things that are going to bring up information that I like. And that's because it's just a lot easier for me to work that way. If I don't like an argument that somebody says to me, I'm going to be like, well, I need to refute your argument, so I'm going to Google search exactly what I'm looking for to refute that. So you want to be really careful about our desire to do that, and people's desire to do that in general, is that we're all working under confirmation biases, and that affects how we interpret information and how we collect data to make decisions. So all this to say, data can be a false authority. We talked about this a lot with like qualitative versus quantitative studies. This is just kind of a larger just thought of, just because I find data that tells me something doesn't mean that I've just proved something. It doesn't mean that I've just found everything that I need to know, because all these things are at work. We have imperfect studies that have limitations. We have the fact that people present data that's cherry-picked, that we find some data that we like, but it may not be the full story in that particular presentation. And I'm also battling anecdotal evidence that drives how I think, and I live under a confirmation bias that affects how I solicit new information. So when we put all that together, it's really hard to find truth from data. There's a lot of things that can go wrong in that process. And so part of being kind of a well-read person, part of being a statistically literate person, is being really aware of these different things, of just like how many hurdles there are to getting to truth, how rigorous that process really is to be expertly informed about what's going on, and how humble we should be as people when we enter arguments, or we kind of look into research and try to find answers. It just takes a long time, and there's a lot of ways that we can be wrong. So be really cautious. Don't treat data as a false authority when there's all these things that we know can go wrong in our ability to discern truth. So in a more scholarly sense, let's kind of turn back into how do we judge research? How do we read studies and read articles and know how good this data probably is? So these are the types of questions that we should ask. Number one, if I'm reading a particular study, is this an observational study, or is this an experiment? because that affects kind of the strength of the internal validity if it's an experiment versus an observational study. If it's an experiment, how strong is the internal validity? What are the threats to a causal change or a causal chain? If it's an observational study, what confounders could exist and how well were they really explored in the data? What wasn't explored? What wasn't really satisfied there? How strong is the external validity? In other words, how well can this experimental setting generalize to other situations? Have the authors cherry-picked data to support their claim? How were the graphs and tables that were presented, percentages and other statistics that were shared? Was all pertinent information available that we should know? Does the argument stem from an objective data source, or was it more anecdotal evidence that affected what was collected? Might these authors have any confirmation bias? And furthermore, do I have a confirmation bias when reading this? Is there a proclivity towards a certain conclusion? Was there a sponsor to the study who is funding the study who might have an agenda here? This should prompt us to look carefully at the processes and what kinds of things could be overlooked. And as a final consideration, am I ready to make an important decision from this data? What further research remains to be done? We don't depend on singular studies to tell the whole story because singular studies always have limitations. Rather, we look at kind of the corpus of studies. We look at multiple relevant studies that study a question from different angles and look to see if there's kind of a common conclusion, a common result stemming from these types of studies. So we want to be good question askers when we evaluate studies. All right, so let's look at a couple examples of data claims that have some flaws, and let's talk about what they are. So here we have a toothpaste company. They reached out to 500 dentists to see if they would be willing to recommend their toothpaste. 54 respond, of which 42 said that they would recommend this toothpaste. The company then publishes the claim that 4 out of 5 dentists recommend their toothpaste. Is there anything problematic about this claim? So we could go about this from a couple different angles. I would definitely use the term cherry picking to describe the claim that's being made, and that's because they are intentionally reporting something that isn't telling the whole story about their data. So I think that would be an appropriate term to use to describe what happened here. Right? So 4 out of 5 dentists who responded recommended their toothpaste, but they're not sharing the information that only about 10% of the dentists that were contacted even responded to the survey. So we could also kind of point this to external validity as well in terms of the sampling that was done, is that we had a really high non-response rate. So I think that's another valid term to kind of bring up to this issue is external validity, 10% response rate, possible non-representative sample, right? So, do the people who didn't respond, were they also, 80% likely to recommend this toothpaste, right? Because I think that's a good question to ask, is that people who didn't respond, maybe they were not, maybe they didn't care. And the people who did cared and recommended. So that's kind of going along with like why the cherry picking is an issue of why it's relevant to know this information in the first place, is that this is a possible bias in the claim that's being made. All right, let's look at another one here. We have emergency room visits, or emergency rooms frequently report higher numbers of patients on major holidays like Christmas or the 4th of July. I believe the reason is that more people are lonely over the holidays and are more likely to engage in risky behavior as a result. What is wrong with my logic here? Possibly wrong. And that is because I am making a causal claim to what is merely an association or a potential association here, right? So it might be true that that people are lonelier over holidays who aren't with family or friends or something like that. But I don't actually know if that's the reason why there's more emergency room visits. Like we could name several things that are different about holidays. So I would say mistaking a possible association with causation here. Because again, what else is special about holidays? There's more traveling. There's more events going on. There's more ways that we can have accidents happen on holidays. And it's not necessarily lonely people who are at the cause of this. It could be, something else. It could be, again, the travel or, the more fireworks or something like that. Like we could make up a lot of different things that could be the cause here. So if we're just thinking about this, I'm kind of, maybe I have a confirmation bias why I think this. I would definitely say there's an internal validity confusion going on here. Is that I'm making a causal claim without any reason to say that. So I just don't have any data to support this other than an opinion and mistaking association for causation. All right, and then I have one more here. I've always been concerned that there might be something unhealthy about protein bars. Then I came across a well-designed, randomized control trial that said that consuming too much protein a day can actually cause some negative health effects for some people above age 45. I now tell college students in my courses to avoid protein bars. Okay, so there's a couple things, again, that we could say. One thing that I would point out is that even though we do have a well-conducted study, so I have objectively sourced data, this is not anecdotal evidence, right? But I'm applying it incorrectly. I'm generalizing it to the wrong population first off. So I'm going to say external validity. Does this apply to young people? The study said that there is possible health detriments to people above age 45, but can I generalize these results to young people? That I don't know. Let's see, is there anything else? I feel like I'm thinking on the spot here. I know protein bars. The other thing that I'd point out is a confirmation bias that I have here, right? So notice how right here it says, I've always been concerned that there might be something unhealthy about protein bars. That means that I'm on the lookout for information that supports how I think, right? So if I already think that's a possibility, then I'm going to pay more attention to studies, or I'm going to be looking for studies that support that. So there might be a lot more research on protein bars and excess protein that tells a more complete story that may not quite align with my agenda here, but I may not be looking for it. So just like the vitamin example, if I already think that vitamins don't do anything for you, then I'm going to be looking for information that supports that rather than looking for information to refute that. And I think that might apply here as well. All right, so we will stop there.